where you have a local area network that may have say 256 computers, but when they go out to the internet, they're going through one single router and using one single IP address as far as everybody else is concerned. That's how we are getting by these days. But it will still run out, very soon, because more houses, more households, more universities are now online. So that does that answer the first question about why we are running out of IP addresses?
I was more interested in the MAC address.
Okay, MAC addresses. Okay, so the first thing I have to do, because the rest of the class may not know what is a MAC address. MAC stands for, is it Media
Access Control?
Media Access Control? I think that. Okay. Well, your professor does not really know or remember everything. So from time to time, your professor will, and you should do the same thing too when you have questions.
Yeah, Media Access Control.
Yep. So what you need to do is to understand the resources. Wikipedia is one of the really, one of the nice, good resources that I trust. Okay, but many professors do not like to use Wikipedia. But for technical stuff, not for political stuff or stuff that is subjective. For technical stuff, I really have no objections at all of using Wikipedia. Well, that and also, synopsis of anime and stuff like that. It's really good for that too. So for MAC address, it is called Media Access Control Address, and that is only useful for certain things. So it will run out, but there are more bytes too. There are 6 bytes to a MAC address as opposed to 4 bytes to an IP address. So you're looking at a much larger potential range of numbers when you compare this to IP addresses. Now, when it does run, okay, the other thing that I want to comment on is the MAC address is not actually, it is hard-coded, but you can actually change it. Okay. You can tell your operating system and say, hey, tell the network card the reported MAC address should be this instead of the one that is burned into the chip itself. Okay? And that is useful for many purposes. When let's say you're connecting to your ISP, and some ISPs go by MAC address. In other words, they identify you are a paid customer, and this is your computer by your MAC address. When you switch computer or when you switch network cards, that will change. And then you have to call up the ISP and tell them, okay, I've changed my computer, my new MAC address is da-da-da-da-da, which is a hassle. So what you can do with some computers or some NICs is you can tell the NIC and say, oh, do not report the number that is burned into the chip. Instead, report this number. Okay? So that way you're cloning the MAC address from the previous computer. Then your ISP will just say, okay, you're the same computer, fine, I'll give you access. Okay? So does that answer your question?
Yeah,
concern?
What do you think we'll do when we do?
When we run out of MAC addresses? They can probably recycle. Okay? The thing about MAC addresses is they only have to be unique within the same local area network.
Okay.
Because beyond the local area network, the MAC address is no longer visible. The IP address or the IP does not include the MAC address. So that means, if you have 256 computers on a local area network, you have to make sure those 256 computers do not, have a collision of using the same MAC address. But guaranteeing that 256 computers do not have the same MAC address is a whole lot easier than guaranteeing all the computers in the world cannot have the same MAC address. So it's not as much of an issue because with a local area network, you can usually go to each computer and find out what the MAC address is. If you do have a collision, you can just tell the software and say, do not report this address and use the other address instead.
Okay.
So I don't think it's a big issue, even if there's a collision and we are running out of numbers.
Alrighty.
Okay, very good. Any other questions so far? No questions? Yep.
What actually does a MAC address do? Because I get IP address, but what's the MAC address?
That's a very good question, but in order to explain that, we'll have to kind of fast forward a little bit into the networking concept stuff, okay? But which is not too bad. I mean, we can definitely do that, okay? So that means we have to first explain a few things that I have not explained yet. Okay, so we'll go ahead and save the document first. This is 2010-0914 cisc310, just in case we want to save it. But the audio and the screen capture is going to be online anyway, so I really doubt anyone wants to read the text portion alone by itself. Okay, so now the question is, okay, the first question is, what is a local area network? Okay, so what is a local area network? The book has its own explanation, so I strongly recommend you guys to read the textbook first. Okay. But basically what a local area network means is it is the smallest unit of networking. If you want two computers or multiple computers to be talking to each other, this is the most basic. This is the lowest level of construct that will allow computers to talk to each other. Is that okay so far? Okay. So we can say that this is the minimal setup for computers to talk to each other, which is a very loose definition of a LAN, but for our purposes, we'll just say that, okay, it's good enough. Okay. So the next question is, okay, let's just say that we have two computers. So I need a little prop here so that we can talk about it. Now, obviously, this part is not recorded on the screen, so you just have to take my word for it when you watch the video. So let's just say that I want this computer to talk to this computer through networking. Okay, so now I have these two computers, and they have to be connected somehow by certain networking topology. Now these days, I don't think we have to talk about some of the older technology like the coaxial cable and stuff like that. So we'll start with a Cat5 cable, which is the most common way of connecting these computers. The other part, that I do not capture in the screen on the screen, is to draw a picture of what you need to do typically to have a minimal setup on on the network. Okay. So we have one computer here. We have one computer here. Now you can, if you want to, use a crossover cable and just connect these two computers together. But that is a very, very limiting setup because you can have exactly two computers connected this way. So most people don't do the crossover cable, and they use either a hub or a switch in between. So what that means is, this computer has a cable going into a box like this, and this computer also has a cable going into a box, the same box. Okay, this box in this case, minimally speaking, can be either a hub or a switch. I will not go into the detail to distinguish these two. We'll just say that they both do the same thing for what we are intending to do. Okay, is that okay so far? Yep.
I heard that crossover cables aren't necessary with gigabit chiplets.
Even with older 100 megabit NICs, it is actually not necessary because they can auto switch. Yeah, many cards can actually auto switch, but the problem is, with a crossover cable, you're still limited to connecting just two computers. Whereas, with this scheme, you can easily add a third computer, a fourth computer, and so on. So that's the only reason why I do not use a crossover cable here. Okay, so the next thing is, but how does this computer know about the existence of the other computer, and vice versa? Okay, right? Now, let's also, in this case, we'll assume the most basic mechanism. So we are not going to do DHCP, which means, you wake up and you say, uh-oh, I don't remember my name. Okay? When you use DHCP, what is the other name of DHCP? There's a more common name to DHCP. I can't remember what it was. Anyway, we are basically assuming that this computer, when it wakes up, it knows, hey, my IP address is going to be 192.168.1.1. It is pre-programmed, onto this computer. You set it up in the operating system and say, you are 192.168.1.1. And when this computer wakes up, it understands it is 192.168.1.2. Okay? So when this computer wants to talk to the other computer, it can just say, hey, computer 192.168.1.1, I need to talk to you. Except how do you know that there's a computer called 192.168.1.1 out there?
You ask the switch. You ask the switch.
No, not exactly. Go ahead.
Does it search for who is out there?
It has to do a search. Basically, it has to send a message out using not TCP/IP, but a level below that, using the frame level communication protocol. It has to go out and ask, who is out there? Who has 192.168.1.1? Okay. In other words, addresses have multiple levels. When we talk about IP addresses like 192.168.1.1, it's actually a fairly high-level address already. At a much lower address, we have the MACs, okay, the media access. What was the C again? Control, ID. So at a lower address or at a lower, level, there's the MAC. The MAC is going to identify the actual hardware, the NIC itself, the network interface card itself. Okay? Are we still doing okay? So the communication between these two computers, you can see that there's TCP/IP. TCP stands for is a transfer control protocol, and then / internet protocol. This is actually a high-level networking protocol already. Below that, we have something else. Okay, we have the Ethernet communication protocol sitting below this level. Now, this is getting into networking topics. For anyone who's really interested in this stuff here, you should take a class in CISN, in the CISN destination. But if you want to see what this is all about, it is called the OSI model. Okay, once again, Wikipedia. That's an entry for that. This is really, really way more beyond the scope of this class, but I just want to show you the picture of all this stuff here. That is not rendered very good because here's a table. Okay, so the OSI model is basically a layered approach to look at the network. Okay, I'll just kind of quickly go through these layers. We can't do anything without a physical layer, can we? Okay, in other words, this is representing the cable that you're using to connect to things, or if you're using wireless, it represents the medium or the radio wave. Data link is the next level. It is physical addressing, and the media or the data unit is called a frame. This is the smallest unit of information that you can transfer between two computers. And then on top of that, we have packets. And this one includes, the layer is called network, path determination, and logical addressing. When you talk about IP addresses, it is actually logical addressing. It is no longer physical addressing. MAC, MAC, media access control, is physical addressing. Okay? Once you program a NIC and say your MAC address is blah, 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 the computer, the operating system, does not have to pay any attention. The NIC itself understands, I will listen to all the frames that has the MAC address intended for me. And the operating system does not have to do a single thing. When you move up these levels, then it becomes more and more involved from the operating system's perspective. Okay? So we get to TCP/IP addresses at about level 3 and level 4. Sometimes it's hard to say where TCP/IP is standing at. But when you talk about MAC address, we are talking about level 2 or at the frame level. Okay? Now, the use of MAC address is more useful when you use DHCP or dynamic